Welcome everybody. This is the third in the sessions with Microsoft and to talk about the use of AI and Azure systems. And Mario is joining us again for the session to go through the way that we can use AI to enhance our research. He is most definitely the expert. I'm definitely not the expert, so I'm going to stop talking now and I'm going to hand over to Mario. So Mario, welcome. Thank you.
Carl, thank you very much. So, welcome everyone. Thank you for joining me today. This is, as been said, third session. Just let me introduce myself for a start, for you who haven't been on the first two sessions. My name is Mario, coming from Zagreb, Croatia. Greetings. I am 16 plus years in IT industry, did many roles, started as some kind of full stack developer, all the way to solution architect, project manager, all the way to roles to the CTO, founders in these days, tied to Microsoft technologies ever since, from Azure Solution Expert Certification, AI Engineer, DevOps, Developer Administrator, and currently, obviously, I'm focused on AI, on this buzzword, which is not a buzzword anymore, AI engineering, solution architectures, cloud consulting, and obviously lecturing. So let us just repeat our journey, how we started and where are we going. In session 1 and 2, we went all the way to some kind of broader perspective from research data problems, all the way from some kind of fair data principles, all the way about managing lots of different kinds of data, structured, unstructured data, and started to talk about some kind of technologies that are available for you guys that you can tackle in the Microsoft Azure to help you around it. So cloud infrastructure, Microsoft Fabric was starting point for us. OneLake as unified data foundation, Lakehouse over that, workspaces in terms of organization of teams and the permission governance, where we started to talk about some kind of data agent on this fabric, where we set up some kind of MVP approached natural language queries enabled data agent, where every answer is auditable, SQL query on that platform, purview, lineage, sensitivity labels, and we mentioned GDPR and European AI Act alignment in terms of this platform. So moving forward to today is the roadmap. We are going to start to talk about AI Foundry. We are going to talk about what that is, about the models, about AU residency, about how you can consume this platform, does it serve you. We are going to again talk about prompt engineering. We already mentioned it last time, but this is important stuff in terms of consuming those large language, small language models, etc., where the power lies. We're going to walk through the Foundry portal to see how this looks like for you who haven't seen this. Talk about the grounding, what grounding is, why it's important, how to ground, what kind of technologies do we have, about the RAG concept, vector indexes, AI search, some kind of managed solution in Azure to help you on certain fields, evaluation, responsible AI, coherence, groundness, AI Act again, obviously. And we are going to talk about AI agents in general. What does AI agent it's contained from? That AI agent is not equal to model itself. That we are going to talk about knowledge options, toolings, interpreter, and we are going to go through some kind of demo about some kind of research data agent that is going to build upon the dummy data that we introduced in the previous sessions. And we are going to talk about some kind of broader aspects and some kind of future details and future learning paths for every one of you in terms of what do you want to know further. Yeah. So having all that in mind, let us start with the session. Okay, so when we're talking about AI, we explained in the last sessions that AI is not a new term, that AI is something that is here from 1956. And just because we have certain advancements and certain new paradigms in this field, that doesn't mean that it's generally new. But synonym for AI these days are, for most of the people, ChatGPT, Claude, Grok, whatever AI agent, AI platform you're using. But let's talk about this stuff. If you have maybe license for ChatGPT, if you have maybe license for Copilot in general, or you're using Claude or whatever, from this perspective, maybe you're using ChatGPT for literature review, you have no version tracking, you are copy-pasting prompts with no documentation, you have no evaluation of output quality or bias, you have no audit trail for ethics boards, you have no kind of traceability of model changes, and these model changes break reproducibility silently. By model changes means that all those big players who are providing these platforms, they are retraining their foundation models with new data, and they are constantly publishing some kind of upgrades, and some kind of upgrades of this model can break some kind of your expectations that was working before, some kind of workloads, you know. From the other hand, what is required? Required is some kind of version model selection with justification. You will see how this is answered and how this is solved on the Microsoft Foundry. You want to have documented problem design as methodology. You want to have some kind of systematic evaluation against some kind of benchmarks, complete audit trail for compliance, and you want to have reproducible pipelines from input to output. That's important stuff. Now, let's introduce Azure AI Foundry as a research infrastructure. So it's been saying last two sessions, we were talking about Fabric as some kind of grounding point for storing large amount of data, structured, unstructured, pipelines flows for ETLs, for doing some kind of background for the dashboarding purposes, even to have some kind of basic data agents over them, which can serve you to investigate and chat with your data. Now we're going to talk how to customize all this and how to have better fine-tuned approach with a platform of AI Foundry. So what is Foundry? Foundry is a research AI workbench, let's call it like that. It's a unified platform for building, evaluating, deploying AI. It's organized in different kinds of, let's say, terminology layers. We have hubs, which is shared infrastructure for some kind of research group. We have projects. Projects are individual experiments within hub. So one hub can have multiple projects in terms of integration. And in terms of this project, you have integrated model catalog. You have playground. You will see playground later. We are going to play around with it. And you have evaluation support through the portal and through the CLI and through the old stuff, and deployment. It maps how research groups actually work. In general, you can see here diagram with some kind of other different Azure resources that can be connected. So from the project's perspective, we have some kind of two types. Foundry project, the placeholder, it's organizational point for Foundry models. You will see later that we have 1,000+ different kinds of models that can be provisioned, after that used by this original version, or maybe even fine-tuned. We have the connections to the different kinds of services, including Azure AI services. On the other hand, when we have hub-based project, we can even have some kind of prompt flow for advanced stuff here, some kind of compute to provision to have inference over there, connection to the external data sources like Azure storage, and underneath you can have multiple different kinds of project. Right now, this is all some kind of virtual, but let's just talk about from the general perspective, and we will narrow it through the presentation. Okay. Key areas. Model catalog. We can browse and compare more than 10,000 different kinds of models. It's important for you to understand, maybe it's something that you know, but it's important to understand that when you are using ChatGPT or Claude or Copilot, you're not using the one unique model in the background. There is no one brain that collects all inquiries and answers to the different kinds of users. You should think this model as some kind of piece of software, like you had some kind of packages before. And obviously, this model needs to live somewhere on some kind of infrastructure. The same thing applies over here. With AI Foundry, you have opportunity to provision by deploy certain model in the region by your choice, which is really, really, really important. By that, you have isolation. You are not sharing those infrastructure with any kind of, you can have even that possibility to not share infrastructure with any kind of other institutions or people or whoever. And this model, since we are not talking about piece of software which is using few gigabytes and one NVIDIA card with some kind of GPU power, we are talking about those large language models that are using large amount of infrastructure to be trained and hosted. So data centers are something that are really, really, really cool stuff for us if we want to focus on and work on the workflows, not on the infrastructure. So you have opportunity to host in a different parts of the world that model by your choice and consume it. So this is really important stuff. And we are not here tied only to OpenAI models. We have lots of stuff. We have lots of stuff from the perspective, even OpenAI models, Anthropic models, from Elon Musk models, we even DeepSeek, Chinese models, Microsoft family of models, lots of different kinds of stuff you can do. We will see it later in the demo that I will show. Important, playground. We can test models interactively with prompts. That's important stuff. So you can play around and test the same prompt on a different kind of model and check the expectations and evaluate this, compare it. By evaluation, you have systematic designing, testing of model outputs. We have managing live models endpoints. By endpoints, that means that every single model that we deploy is available via HTTP request, and we have support from the multiple different kinds of SDKs to consume it. By SDKs, I mean technology from .NET, Python, Java, and lots of more. So this is not some kind of explicit programming language related. You can, with your own existing knowledge, access this. So you have some kind of endpoint, you have some kind of key for authorization, authentication, and then you can integrate those models into your workloads. And which is important stuff as well, and we will show it in a demo, you can build up agents. So we can build up AI assistants with different kinds of tools. We will see it in a demo today later. Model catalog. Already been said, lots of different kinds of models from OpenAI, Meta, Mistral. Important to say Mistral as well, our European company. Microsoft, different kinds of models. On the right side, you can see how this thing look like from the portal perspective. This is the central repository of models. You can even provision those third-party models like from Meta here and others to manage, to understand, and for easier navigation through this, you can filter it by task. Either we're talking about some kind of text generation, either we're talking about embeddings. You have those kind of models, image generators or image understanders, code models, different kinds of categories. You can filter by license, open weight, proprietary, by region, EU data residency compliance. Each model shows capabilities, benchmarks, and pricing. That's important stuff here. By EU data residency, we need to address this, which model stays in Europe. So this is the key principle. You are choosing the data center where the model is going to be deployed. We already mentioned in the previous sessions that Microsoft has 70 plus data centers around the world, and this number is constantly growing. So they're heavily investing in this infrastructure. So when you deploy model in Sweden, Central, for instance, or West Europe, your data stays in EU borders. All prompts, all completions, all fine-tuned data are processed and stored in European data centers only. That's important thing to understand. So you are in control. You are in control. Either you want to deploy the model or in America, Japan, whatever, but you're in control. This does not fly around the world. You're in control. Deployable models included. This is just some kind of sneak preview, some kind of glimpse, a small glimpse about the models that are deployable. GPT-4.1, this is from now's perspective, older model, but it's still heavily used because of the token range, you know, and the performance and value for money. GPT-4.0, 4.0 mini, for instance. Now you have OpenAI guys recently did publish the GPT-5.5, so you have lots of options over here. Mistral large, Mistral small, 5.4, 5.3.5 from Microsoft, open weight models via managed compute, self-deployed. Just a few sentences about this. Self-deployed, that means that you are responsible for infrastructure. You can easily through this portal provision set cluster of virtual machines with certain configuration that is needed to run model. So you're the one that chooses GPU powered with different kinds of families of the GPUs in the background. And you're the one who is then responsible for handling this inference, deploying those models there, and handling the infrastructure. But why is this important? Because you have opportunity. Not just to give Microsoft to manage your deployments, you can do it by yourself by provisioning infrastructure. Comparing models with benchmarks, there's a different kinds of benchmark. I will not go into details right now, but some of you maybe are familiar with it. Common metrics in general are quality index, accuracy, cost, coherence, fluency, GPT similarity, groundness, relevance, latency. This is important stuff for comparing. Cost, price per token, 1 million tokens, input, output, side-by-side comparison in the portal, choose based on research needs, accuracy, vs speed, vs cost. So this is important stuff for you, when you're having 11,000 plus models that you can pick, it's hard to for if you don't do some kind of benchmarks and do some kind of comparison and ideation about some kind of your workflows, it's hard to choose. But this portal gives you opportunity to compare different kinds of models and to choose the best one for your particular case by different kinds of evaluation points. Deployment options, we just mentioned it, but let's talk about it again. Serverless API, the easiest way. You provision it, the model, it's behind the serverless API. What does it mean? Microsoft automatically deploys this model into some kind of, let's say, it's containers, clusters in a background, and they are providing to you just API, and you're consuming this model through the API. It's the easiest way from the perspective of the end user. So you're paying per token, no infrastructure, is the fastest to set up. It's the best for experimentation, and most OpenAI and partner models are in that kind of way. Managed compute, I already did a few sentences about it. We have dedicated virtual machines. We have reserved capacity, predictable performance. This is the best for production sensitive data. It's required for open weight models. That's the some kind of from MVP phase to the production. Once when you get some kind of insights, how many usage is there per models, etc., 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 then you can easily switch between those. And you can have connected resources. You can bring your own endpoint, use models hosted elsewhere. What does it mean? Maybe you have a model hosted on some kind of private cloud in Europe. You're managing this. Maybe you have model hosted in AWS or whatever. You can set it up and bring up the endpoint there. Why do you want to do that? Because you want to manage every single stuff. You will see later parts of observability, for instance, traceability and stuff like this. You want to manage it from the same place, same portal. You can do that. So those are the deployment options. Once when you have model up, you want to consume it. You can check the diagram on the right side. You are in the position of doing some kind of coding. Either you're talking about, I don't know, cloud code, or you are doing it manually still or whatever, but you want to consume something that you provision, something that lives in cloud in Azure, and you're doing it by Microsoft Foundry SDK. So this is, you can see here, you as a developer, you have Python, and not just Python, you have .NET, Java SDKs, different kinds of programming languages, which gives you opportunity to create, deploy, and manage models from the code, infrastructure as a code. You can integrate it with this SDK in your existing Jupyter notebooks, do some kind of stuff with MLflow technology, version AI pipeline alongside research code, full reproducibility, model selection to evaluation. So this is some kind of tool chain where you are connecting yourself to the project, Foundry project. And this Foundry project, maybe you are connecting to the OpenAI service, maybe to the AI search. We are going to talk about it in the next couple of slides, maybe to Foundry agent service or whatever, but you are doing it from one single point of entry point, and you're doing it through Microsoft Foundry SDK. Okay, so it's been said, connections to access resources, write code using their own APIs. That's a cool stuff for you. Okay, so just to wrap it up from the perspective of Foundry as a research infrastructure, some kind of summary. This whole platform gives you model selection, support, over 11,000 models with benchmark comparison, task-specific filtering. You are the responsible for the deployment, and you have possibility to do that. You have EU data residency. You are deploying in Sweden Central. Data never leaves EU. Is GDPR ready. You have reproducible SDK, and you can manage it everything by the code. If you're going to talk about integration in some kind of DevOps, it's called AI Ops right now, workflows, you can use this SDK to automatically do some kind of stuff. And you have evaluation pipeline. So manual automated evaluation, content filters, responsible AI. So this platform gives you opportunity to deal with the latest state-of-the-art models, from the provisioning, consuming, evaluation, traceability, everything is there. You are using infrastructure as a code or whatever way you like to do it, which is important stuff. Let's switch to another chapter in today's session. Let's talk about systematic prompt engineering for research. Why? The ones when you have this model running or set of models or whatever, you want to consume it. And you want to consume it by how? By writing a prompt. And prompting the prompt is nothing less but some kind of programming language for large language models. You can think of it like that. It has some kind of patterns. It has some kind of syntax that large language models likes or dislikes, and it's really important for you from the perspective of the end user. And when we are all prompt engineers to understand those patterns, so you can be better in commanding and getting the desired results from those models. Okay. Anatomy of the prompt. This is generic stuff. This is not related only to a certain model, I don't know, GPT-4.1 or 5.5 or whatever. This is generic stuff for the technology itself. So you can, this is unique knowledge, it's important to say, but we need to definitely understand the difference between those. We have system message. This system message is some kind of initial prompt. It's some kind of grounding prompt. It defines guidelines, model behavior, and which is important stuff, defines some kind of role. That's important stuff here. We're going to have some kind of examples, but you can think. You are my assistant in this field for this purpose. Your job is to advise me about that. On each user input, you need to give output in this format. You need to be precise. You need to be this. You need to be that. This is the system prompt. You are the one who is controlling this, and you are the one who is responsible for writing this kind of stuff. Obviously, user prompt is specific question or task when user is chatting with an AI agent, with the model itself directly. That's his input there. Using this system prompt as a context for a start, plus later we're going to talk about AI agents, about additional context, which is needed in these days to get the user better experience and better experience in general. We have completion, that's the model response. That's the context, content generated by the model. This is the input, this is the output. And we have some kind of history. This is the, when we're talking about the history, we are talking about, you are opening chat, and all this chat history is entering the next question from the user or next input from the user. Why? Because of the context, like with human. So for instance, you can think of it when you meet some human who is very intelligent, and you met him for the first time, and it's up to you to explain to him your intention with him and what do you want from him. People are not telepathic, models are not the same. The better you are in that, and the more you have conversational history, context is broadening, and it's much more probable that the output is going to go in the direction that you want from this human. The same thing applies to the models, whatever model you choose. Okay, so here on diagram, you can see by the colors, different kind of stuff. We have system prompt plus user prompt gives some kind of completion response that builds up conversation history, and conversation history, which is contained of every single stuff that happened before, plus the user next prompt enters the model, and that builds up. That's the idea behind it. So you probably understand this from your current usage of tools like ChatGPT or whatever you're using, but it's important stuff for you to understand those kind of different types of the prompts, because in the foundry and the playground, when you will be building AI agent, you will be the one who is responsible for setting up system prompts and tweak all the stuff behind it. Okay, this is one example of system message. It's related to our previous examples that we had on previous sessions. So research system message example, you are water quality research assistant. You can see from here that I've been setting up in some kind of role. This, you analyze data from European water quality monitoring, some kind of brief intro about what is in this data, rules, only use data from the provided data sets, cite sample counts for every statistical claim, state confidence intervals where applicable, acknowledge limitations in data coverage, never fabricate citations or statistics. That's important stuff. These rules, important from this to take away that you are responsible for writing a good system prompt. In the real life scenarios, there are tools from the AI who helps you to write a really good system prompt. So system prompts in general are not that kind of small. They can be really large, explaining lots of the details about desired behavior of the system. When we're talking about the models, this is just example. Not all models do have this, but this is some kind of standard thing. One thing where you control the narrative and the behavior is system prompt. The second thing are some kind of parameters that are enabled for you to tweak from the model itself. Every single model has different kinds of parameters. Those are some kind of generic. For instance, you have temperature. It shows you it's the value from 0 to 1, like 0 to 100%. It shows you, it controls randomness of output. For instance, for some kind of research setting, it can be small for analysis from 0 to 0.3, or if you want to have some kind of assistant that will help you for brainstorming how to approach of resolving some kind of problem or challenge you can do some temperature of 0.7 to 1.0, top P, vocabulary diversity, 0.1, it's really factual, 0.9 is creative, you're giving some kind of space to the model to be creative or not creative. Max tokens, this is the limit of response length limit. It's based on expected output. Obviously, if you want to from the model to produce some kind of straight answers in a few sentences, you will not set up this to the, I don't know, a few hundreds of thousands of tokens, depends on the model to model. You'll be smaller if you expect from the model to give you the large output, maybe several pages of something that should be read, then you will increase it, but you are in control to find to this. It's important stuff, these max tokens, and there is some kind of stuff in the hosting tokens per minute are something that is important for you to handle because of the charging and pricing models in the Azure, but later. Seed deterministic output, same seed, same output. Yeah. Optimizing model performance, when to use what. Right now, we are moving forward. We are responsible for system prompts, we are responsible for model choosing, and we have scenario, we'll have set it up our system and the model, but for some reason we are not satisfied with either performance, either the quality of the outputs. We have multiple choices over here, and the Foundry is giving us opportunity to deal with this. So we are optimizing for context when model lacks contextual knowledge, and we want to maximize response accuracy. By mean, we already spoke last time about some kind of concepts, but let me go deeper in it. Those models, large language models, foundational models are trained on the public available data in that point of time. Obviously, you in your institutions have some data that is not publicly available, and maybe it will never be at some point of time through this research period. But you want to leverage this. You want to give the model opportunity to ground it with this. Why? Because model can then have bigger context and give you the better responses. Always remember this analogy that I told you about the human being, which is highly intelligent, but if it's not aware of different kinds of knowledge structures or where this is contained and what kind of stuff can be used in the context, he will not be able to give you the correct answer. Same thing applies here. So you can optimize it for the context, and you can even optimize model when you want to improve response format, style, speech, maximizing consistency and behavior. We have two choices here, let's say, axes here, not choices. We can, if we want to do some kind of easy tweaks, and this is cool stuff with us, we can definitely do some kind of prompt engineering by arranging this system message. You know, you remember that I told you that you are in control to do that. We can set up tone, format, content expectations, detailed, explicit user prompts for better responses. We can do that in a system message. I told you that in the real world, system messages can be pretty intensive and long, explaining lots of different kinds of stuff. On the other hand, if you want to bring up more context, we can do RAG, retrieval augmented generation. That's something that is, I would say, standard these days. What does it mean? It gives contextual search results to the prompt. How? By using certain techniques that can connect your data model to your institutional, to your knowledge base. This knowledge base, we will see later, can live in a different kinds of structures. From the less complex, like a pure file document repository, or maybe complex one that requires vector databases. That means that you need to chunk the data. Maybe you have the data in thousands of PDF files, plus videos, plus images, or whatever. Then you can do some kind of indexing of this data, do some kind of the stuff that is called chunking strategies, and you can push it into vector databases. Azure AI search is one example of this. And you can then build up the mechanism which will help you, the whole engine, the model, to get the required context to answer the best for you. So that's the RAG. Fine-tuning, it's additional model training with example prompts and responses. By mean, you are using foundational model delivered from OpenAI, for instance, and you are building up training data set with examples of questions and answers, and you are then starting retraining. You can do that in a Foundry, and you have your own fine-tuned model. That's the one thing in terms of the model optimization. Or you can do both. You can combine stuff here to have the best results. It's not written somewhere which is the best. Definitely you need to check by your expectations and evaluation and the quality of the responses, what serves you the best. But here are just techniques that are available to you, and those are industry standards today. How can you increase context optimization and model optimization in terms of the quality from the both sides? So you can combine all those stuff. Maybe you will, in 90% of the time, resolve your context optimizations by doing RAG. Maybe you will, in some point of time, need some kind of fine tuning with some kind of researcher field definitions and data specifics or whatever. And maybe you will combine this. But important stuff here is just to take away that AI Foundry, Microsoft Foundry platform enables you to do this everything in the cloud on the infrastructure. Okay. Prompt engineering best practices. We will not go in depth. There are lots of workshops, lessons about this, and hands-on workshops, but just to summarize the things that I try to explain to you, that you are in control of it. You need to be the one who will set up, if you're setting up the AI agent and some kind of field for end user to consume the model. You are the one who are responsible for writing good system prompt. Then you are the one who is responsible for writing good user prompt by asking the AI on the correct way to give you expected responses. So you need to define clear role definition, separate instructions from the data, use delimiters, context sections, specify output format explicitly. You have different kinds of techniques here. Few short examples for consistent format. You have a chain of thought for complex reasoning, step-by-step decomposition, negative examples for boundaries. Those are some kind of stuff that are intuitive for us people from the perspective of everyday conversation, but it's important to address it here as some valid techniques to achieve the best from the models, from the large language models hosted. Okay, maybe for you, you need to require citations for all claims, mandate confidence levels, include data limitations in prompt, and you can even version your prompt in a Git. So that's the normal thing today when you are doing this. So you have completely visibility and tracking of the history of the changes of the prompts. Okay, let's check right now. We will connect to the AI Foundry portal and give you the glimpse, a sneak peek overview of it. In the meantime, while I'm switching to my browser, does any one of you have any questions? Go ahead. Feel free to go ahead.
Just one quick one, Mario, actually. You talked about citations. There have been examples of AI systems essentially hallucinating and creating their own fake citations. What are the best techniques to kind of avoid that? Because if they say, yes, I found this research paper and so on, and it literally doesn't exist, I mean, what recourse do you have? What techniques can you use to avoid that?
Okay, thanks, Carl. So in general, when you're building production-ready AI systems, you will definitely link them to some kind of knowledge base. This knowledge base can live and will live in some kind of other structures than AI Foundry. And the whole concept of where AI Foundry can help you is to speed up the fetching of the original data and give the end user exact link to this data where it finds it. By mean, that means you can connect your AI agents to some kind of repository, SharePoint list of all PDFs with some kind of researcher. That means that AI agent, when you're constructing this, will in a chat give you some kind of summarization, explanation why he answered this to you, but with some kind of links to original papers. Your responsibility is definitely to read this and to check it. You need to put yourself in a position these days to critical thinking. Obviously, we are here in a researcher domains. This is something that should be natural for all attendees over here, but it has been never more important to address this, that do not take any kind of information dogmatically, not just from the perspective of hallucinations of the model, but from perspective of that currently situation is that lots of AI agents on the internet on public are building with not so nice how to say people are not with well intentions behind it, and they are putting in the AI models some kind of crappy stuff that are not correct. There are some kind of jailbreak rules, not just jailbreak, some kind of content policies which can inspect those kinds of stuff. But in general, currently we are the only last defending line between the truth and the not truth. So in general, even the AI Act requires for every single AI agent to display the reference from where the data has been taken. So that's something that is law is forcing us. AI Foundry can give you easy way to achieve this if you're building some kind of chat interfaces, and you have your model, which is then connected AI agent to some kind of grounding knowledge, then automatically you will get reference from where this data is. So in general, my question to you is, there is no 100% stuff where you can trust these systems 100%. The same thing applies if you have, you're leading your team lead and you're leading the team from 5 people, 5 members or whatever, and they're combining you with something. You gave them a certain task, but if you are the team lead, you need to check it, you need to read it, and you are responsible for the performance of whole team. The same thing applies here with the AI, and that's pretty much it. Yeah, I don't know if I answered to your question in a way you wanted.
No, that's good. So it's basically making sure you have clean data as the data source, and to actually take responsibility yourself and not just blindly follow exactly what's said without doing those checks. So yeah, that's absolutely cool. Brilliant. Thank you very much, Mario. I'll let you carry on. Thank you.
Yes, thanks, Carl. Yeah, for sure. So as been said in the last couple of sessions, we said in this data management IT vertical, garbage in, garbage out. That applies for the data that is used for training models, that is applied to the data that will be used for some kind of grounding of the models. You are responsible for the cleaning of that data and the cleanliness of this. That's important stuff. And as well, you have all the opportunities to affect on all those pieces by AI, and AI Foundry, just one of example of technologies that can help you here. So let me just show you the AI Foundry portal. Can you just give me a signal? You can see the portal? All good? Yeah, I can see thumbs up. Great, thanks. Okay, let's go from the scratch. I already did provisioning of it. This is the Foundry portal. It does not exist by itself. You need to, from the Azure perspective, provision it. I already did the AI Foundry, and I created the project already. So we have opportunity right now. Just let me. Okay, we have opportunity right now by clicking on this, open the portal, and we are then here. So Foundry has this is some kind of general overview that you will find out here. You can see different kinds of projects that you have here. I have multiple projects. You can create new, either foundry resource, hub resource. Okay, we talked about it, about foundry research. It's access for the models, tools, agents, lots of the stuff. Hub, for instance, it's more broader stuff where you can do then ML training, open source model hosting, fine tuning. We talked about it, Azure machine learning integration. Yeah. So having this in mind, let's just jump to the project already created. And once when you are here, you have multiple different kinds of stuff that you can do. You have, remember that I told you about the access stuff. You have access information to access the project from the SDK that we mentioned. Here is some kind of endpoint. You have API key for this from different kinds of libraries. If you're using some kind of Azure OpenAI services, you can do with this library. If you're using Azure AI services, you can do it with these endpoints and stuff like this. But it's important here, some kind of project details, location. Important stuff is that you have links to the documentation. Nobody expecting from you to know everything. So here are Microsoft Foundry SDKs and endpoints. You see here that we have Python, C#, TypeScript, JavaScript, Java, different kinds of approaches, how to use this. You have links to some kind of different kinds of verticals, what you want to do, build agent, choose right model, experiment, fine tune, debug, etc., etc., etc. Okay. Or even you can explore different kinds of templates for building different kinds of workloads. And let's go step by step by checking the model catalog. Okay. Sweden as a region in Europe is one of, in Europe, the regions where the new stuff is being provisioned for us, for end clients to test around before it's publicly available. You can, in Sweden, test certain technologies like new models or stuff like this. So currently in Sweden, you see here that we have, as been said, this is not just related to the one vendor of the models like OpenAI. We have Grok, for instance. We have Whisper. We have GPT, DeepSeek Chinese, Image 2 from GPT as well, Kimi, Chinese model as well, Opus 4.7, okay? You have lots of stuff. And as been saying, when you want to provision some kind of model, you can filter it by different kinds of categories. Okay, by some kind of collection from, let's say, let's check what kind of anthropic models are available there, Opus 4.7, 4.6, okay, different kinds of stuff. If we click on a certain model, then in a few seconds, this is going to show up, and we can see the lots of the metadata about it. We can see which licenses. We can see some kind of details. You cannot fine-tune this model. There are certain models that you can fine-tune it. If you're not familiar in general, what does this model do? You can read it over here, okay? This is some kind of response that is going out from the model, the input, and this is some kind of response that is going out, okay? You're the one who is interested in all this. We have here some kind of benchmarks and some kind of scorings for agent coding, for test name called BrowseCamp or whatever. You can see how Cloud Opus went in this AI arena, that if this is important for you, it should be important for you, okay? And you can then have opportunity to use this model. By mean, for some models, you need to pick up some kind of industry that it's required for them, for their compliance and stuff like this. Some models that some providers that does not require this from you. Let's say that we are from healthcare, whatever. We read all this stuff. We can then agree and proceed. I will not provision this model right now because I have some kind of models provisioned right now. Important stuff here is that we have playground. Playground enables us to play with different kinds of models, not just models, but agents in general. We can click on the chat playground. Okay. We have already provisioned in this project two models, GPT-4.1, GPT-4.1 mini, and we have from the playground possibility to tweak all those stuff that we already have, that we already talked about. So, for instance, let's tweak the system prompt over here. Okay, I just copy paste something. You are a research data agent specializing in blah, 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 blah. Okay. This can be our input, and we can then use the foundry with this to generate the proper system prompt for us. If we're not satisfied with this one, it's going to work in a background and to do this for us. Well, okay, you can see here, it's so much larger than it was before, because it adjusted, it applied. You can do some kind of examples over here, which is important for different techniques to give the examples to the whole engine how to answer. You can even do some kind of safety system messages. In terms of when we're talking about safety, we are talking about some kind of content policy. Obviously, those models are trained not to reproduce any kind of stuff that should be harmful for the user, but some kind of safety stuff can be domain related, and we are in a full control to set up all those pieces in fine-tune it. We can add our data. You remember that we talked about the grounding, expanding the knowledge base. We will not do it. I will later show you the AI agent already built, which is grounded with certain data. You have possibility to do lots of the stuff, ground the data from Azure AI search, which is the vector database. I will not go into depth right now, but this is the new type of databases where we have automatically applied, let's say, this fuzzy search. We have mathematical statistical findings of the terms for the input, which is really cool for the searching of the large amount of different kinds of, for a start, not related text or image data or whatever. Data is converted by embeddings into some kind of vector fields, and this is then searched by some kind of mathematical operators beneath, and the results are coming back. And this data can be really, really cool if you want to vectorize. I said in an example, lots of some kind of PDFs or unstructured data that is sitting in our document management system or whatever, and we want to give opportunity to the AI to look over it and to have this as a part of the context. This is the way to go. Azure AI search, we can even in a Cosmos DB put it, Elasticsearch, we can ground with some kind of public web address, or we can upload the files in general. So those are the data, our data that can be set up here, data source, yeah. And remember the parameters, okay. Remember the temperature, top P, completion tokens, past messages included in terms of the history, which is going to be exchanged, force cutting the output when this string occurs. You can put some kind of safety wording inside, etc., etc., etc. Okay, having this in mind, let's play. We already set up some kind of system prompt, so we should have some kind of identity of here. Let's ask, who are you? Okay, I'm agent. Okay, beautiful. Okay, would you like to analyzing blah 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 research question? You see here that here is aware of our context, European water quality. Why? Because I put it everything here in the system prompt. So this is just some kind of sneak preview how you can easily test the different kinds of models. You can provision multiple models and you can test the output of it by changing the stuff. Okay. For instance, we tested the GPT-4.1 model. Let's chat with GPT-4.1 mini. Okay. His GPT-1 mini is trained on a different kinds of data set. It's lighter, it's cheaper, etc., etc. But the main point here from the playground, you can test different kinds of models with the same system prompt. You can tweak it, you can play around with it, or even when you are cool with stuff over here, you have opportunity even to deploy as a web app this kind of playground. Why is this cool? Because you want to share this kind of playground with the rest of your community or audience. So we will go later. Beside this, I will show you how to create full agent. We have some kind of templates that can help us to connect different kinds of data sources and to leverage this really cool power stuff from the AI agents. You see here, getting started in AI chat. You can start with some kind of template, getting started with agent, multi-agent workflow in this today's workflows and scenarios in production. You have opportunity, you see here from the Microsoft Git repo, to go into whole solution architecture, quick deploy it, lots of stuff. Okay. Tracing, monitoring has been said, it's full connected over here. By these features, you can check consumption of the tokens, latency, groundness, all those stuff here, maybe to check even when you have complex agents build up in production, to see how many time has been spent on a large language model, how many time has been spent on executing some kind of toolings, etc., etc., etc. Evaluation, evaluation layer here, where you can set up quality, safety for AI applications, AI agents, everything that is consuming AI, and you can do those evaluations. Set up guardrails, controls. This is, has been said, something that is built in already in the models and in this whole orchestrating area, but you have possibility to fine-tune this. You can do your own custom content filters. So you are denying some kind of conversations that are occurring from the user perspectives. Evaluation of the risks and alerts, governance, lots of stuff. And overview of your assets. From perspective of model and endpoints, currently in this project, I'm having these models provisioned. It's important to understand those models are, we can click on deployment to check the details. You see the details over here. You can see who created it. You can see some kind of rate limit tokens per minute. You can see the model version. You can see as well how can you consume this. Either we're talking about the language Python, and you will consume it through the Azure OpenAI SDK with authentication type key authentication. You have code snippets, how to do this. So everything is on one place. Why is this important? Because you can, from your notebooks, you can provision model over here, and you can consume this model from the Jupyter notebooks or whatever you want to use it. So Foundry gives you opportunity to organize your AI provisionings, your workloads, and consume it, and to even trace it. How is this used by quality, by price, by latency, and all those metrics that are behind. Okay. Let me jump to my. Okay. What we just saw here, model catalog, more than 1,000 different kinds of models filtered by task, region, license. Sweden Central, currently this is hosted in the Sweden Central that keeps data in Europe, benchmarks. You have different kinds of benchmarks to compare models, playground, set up system messages, a protocol. You can set change the temperature, all those stuff that are related to the different kinds of models. You can compare models with same prompt, different models, choose based on your needs. That is all under one cap, under one platform. Right now, I'm going to switch on grounding AI and research data. We already started to talk about it, but it's really important for you to understand it, because without proper grounding, you will not get proper desired outcomes. So large language models generate plausible, potentially false text, fabricated citations that look real but not exist. We addressed this already with a question from the Carl, statistical claims without data foundation, confidence answers based on training data, not ours. Grounding is what? It's the process of connecting model to verified sources, and we are responsible to do that. So grounding provides specific context to provide accurate, relevant responses. So without ungrounded, let's see on the left side, what product, let's say that we have some kind of original training data and we have model, and the person asks, in this particular case, what products should I use to do something, whatever. Model response is grammatically correct, but uncontextual as a response, which can be false, you would say hallucinating or whatever. Grounded, on the other hand, is giving the model opportunity to fetch the data from some kind of product catalog in this case, or this can be, as I already explained, researcher catalog, whatever that is, of previous articles or whatever that catalog is. And then model has opportunity to use this data as a broader context and give the better response. Grounding is all about that. RAG, retrieval augmented generation, already talked about it. It gathers relevant data to include whether the prompt for the language models to use grounding context. So it's architectural design. Let's check it here. We have this vector-based index. This is the, I was trying to explain, those are the specialized databases where you indexed your data. And those databases are a piece of technology that are optimized for fuzzy search and for really cool findings of relevant data. So user can ask something, vector-based indexed, for instance, for this basic text is transferred text into indexes into the areas of integers. It looks like this. It's not readable to our humans, but the database can do lots of the stuff from it. And based on that, on the first step of our workflow, engine is going to retrieve grounding data based on user input. Then with user input, this grounding data will do augmentation, that is called prompt with grounding data. Everything goes into model, and then model has the better chance to answer stuff. How reg finds relevant data, documents converted to embedding vectors. Vectors are stored in a search index. Azure AI search is one of the possibilities. User questions converted to vector. Nearest vectors, most relevant docs are retrieved. Retrieved docs insert into prompt context, and model generates response grounded in those docs. So this is semantic search, understands meaning, not just keywords. Reg versus fine-tune, which to choose. On the reg, on the other side, we said that we have separate knowledge base. On the other hand, we can fine-tune the base model, and not all base models are allowing us to do that Foundry. So fine-tuning shall be done when changes model behaviors and style, requires training data compute, it's higher cost, longer to implement, it's best for domain language output format, use when model think like your domain. In general, you will either do combination, either just reg. You will never do with only just fine tuning, because lots of the stuff is changing on every single domain. Data changes, you need to retrain the model, etc., etc., etc. So this RAG concept is so popular. RAG with AI search is strictly that I just explained to you, that Azure AI search is the one, it's managed database that holds this AI in this vector index. It's built-in integration in Foundry. You saw on a demo with the playground that we could easily connect to it. We can do lots of the stuff like hybrid search, semantic re-ranker. It supports PDF, Word, HTML structured data. Why is this important? You can push even the PowerPoint presentations, videos, images. You can push all the data into and convert it via embeddings into vector index, and then connect to the AI Foundry and be able to consume it to the models. And that's the beauty of it. So we are indexing our data in Microsoft Foundry using Azure AI search. We are then connecting to it and using this connection to open AI chat client from the project. So we are now in a domain where we have model and we have Azure AI search hosted in Azure, and we are playing around from building some kind of chat client over there that is going to consume this, and we are going to include Azure AI search connection details in those calls, and this will enable us to do the RAG in a Foundry. Fine-tune for domain adaptation, you can do that. As been mentioned, you can train model on the specific data. Model learns domain vocabulary patterns. It requires curated training examples. You need to have training data set, obviously. It's available for selected models in Foundry, not all been mentioned, and you should consider only if RAG has been tried first. So this retraining, fine-tuning of the model is just maybe some kind of addition to the general concept. Okay. So you should remember foundation model plus training data is fine-tuned model. Moving to our next chapter, evaluation, AI outputs, responsible AI. I showed you just glimpse, but in general, you will see on the right side portal how this evaluation looks like. Idea behind it is in terms of some kind of manual evaluation versus AI peer review. Human reviews score AI outputs on defined criteria. Does you're wondering, does response make logical sense? Is the language natural, professional? Are claims supported by provided data? Does the response addresses the question? You are asking all those questions to yourself. And you can do this through the portal. You can evaluate prompt responses, specify context data source, define a set of test prompts. You can compare actual answers returned from the model, and you can score with thumbs up, thumbs down, vote for each response, and have immediately some KPIs that will give you the answer about the quality of it. Automated evaluation metrics, we can have multiple groups of them. We have quality metrics, coherence, fluency, relevance. It's computed by evaluator model. Safety metrics, groundness, content harm detection, protected material check, jailbreak attempt detection, and you can set up some kind of custom metrics if it's relevant for you. Domain-specific evaluation, citation accuracy check, that's maybe important for the case that we talked about in the this case where these references are really important, but the end user human needs to evaluate this. Statistical validity, define our own rubric. Okay. You need to think when we're talking about some kind of safety and responsibility in this model-driven and AI-driven systems, we need to think about multiple layers of it. We need to think about model layer. That's the safety built in the model selection. As been explained, all providers of the models are building some kind of layers of stuff in it, so you cannot reproduce the content which is harmful for the human. But you are responsible for writing system messages. You are constraining behavior of the model on the second layer. Content filter above, you are the one in the foundry, there are some kind of built-in content filters, but you are the one who is responsible for detecting and blocking harmful content. You are the one who is responsible on the second layer to monitor the stuff, track outputs in production, and you're the one that needs to take care of everything. That defense is nothing, it's not related only to the built-in defense in the model. Every single layer above is something that you are responsible on and you have opportunity to affect on. Content filters, prompt shields. You see here some kind of filter categories that you can set it up. Hate, fairness, the text discrimination, stereotypes, slurs, sexual content, explicit, suggestive content, violence, physical harm, weapons, threats. That's for sure important stuff in these days. You know, you need to provide detection from the end users, not to ask any kind of question that can that the response can be used in building some kind of stuff that is harmful for the human. Self-harm, or even that self-injury, suicide references, prompt shields, jailbreak attempts, prompt injections. This is by some kind of severity. Why is this important? Because you have platform that enables you to fine-tune this stuff, and you are the one who can then put on the hosted model in the foundry content layer above it. You're the one responsible for this. AI Act, what you should know, effective from the last August. We have regulation that we have some kind of multiple risk categories over here for minimal risk, limited high risk of all systems that are using AI. You should definitely disclose AI-generated content in publications, log model selection prompts, parameters, know where data is processed. A researcher reviews and validates all AI outputs. So you can do this for sure. Evaluation, responsible AI, summary. Here, quick, you should for sure take care of this to define evaluation criteria before start, run manual evaluation, set up automated evaluation for monitoring, configure content filters, document system message, log all models, verify AU data, and disclose AI per European AI Act. So that's some kind of responsibility by law enforcement, and AI Foundry gives you opportunity to do this. Okay, we had now some kind of brief overview of the platform and what can be achieved over there. We are going to switch to the AI agents, and we are going to show how you can build up on a fully managed infrastructure, those kind of stuff there. So what are AI agents in general? And we need to understand the difference between just consumption of the models and what AI agents do. AI agent is something that is not just ready here to give us the answers on a certain data. AI agent has possibility to execute actions, tasks. AI agent has possibility to have some kind of memory. AI agent has some possibility to do decision making, rationalization, not just summarization. And that's important stuff for us to understand. So agent is model plus knowledge plus tools. Model can be different kinds of stuff. For one GPT, for instance, knowledge can be different kinds of stuff. Either it's in AI search, in Fabric, it's pure files. Tools can be anything. We will see, we have some kind of code interpreter tool, which is connected to our AI agent. We can have functions. We can have connected, I will not go in depth, but today's standards are MCP servers. Those are some standard protocol that gives AI agent possibility to have execution on the multiple different kinds of tools. The idea is that agent plan and execute multi-step tasks. And this is the standard these days, and this is all fuss about, you know. Smart software services combine generative AI models, contextual knowledge, and tools to automate tasks. For instance, we have here example, some kind of expenses agent. He asks, user asks expense agent question about expenses. Agent accessed questions as a prompt. Use knowledge base. We grounded this agent of expenses policy information to the prompt. Agent use language model, which is the central point of everything, to interpret the prompt, generate response. Based on that, agent can use available tools to do the action, submit some kind of claim to be processed, and generate a check payment. So that's just one example. You can think of, definitely from your perspective, lots of probably different stuff that you can combine and do inside of your organization in terms of the agents. And what's important stuff here, why we're talking about it today, because you have full support for do this in the Foundry by using Foundry agent service. You can create agents directly there. You can select model, attach knowledge sources. You can configure different kinds of tools, code interpreter, file search, functions, whatever that is. By functions, I mean a connection to some kind of HTTP endpoint or stuff like this, which can be anything. You can test in the portal before deploying, and agents maintain conversation state and the context, which is full important because of the traceability, AI Act stuff, and everything that we talked about it right now. We are going to do this in demo, but in general, in the terms of the steps, from the portal, you can deploy supported model, create agent, configure, name, model deployment instructions, tool connections, test the agent in a playground, connect and consume agent using the code, which is cool stuff. You can integrate it. You can set up the orchestration by agents consuming agents and stuff like this. This is the modern stuff that it has been done today. Knowledge. Agents are nothing without knowledge. We already explained this. Foundation model in the center, in the core, is responsible for summarizing, for rationalizing, decision making, but without the knowledge and access to the proper knowledge, it does not have context what to do in general. So we have different kinds of knowledge tools supported: file search, Azure AI search, Fabric. So Bing search, important stuff here as well. You can connect the AI agent to the Bing. It's a web browser crawler from the Microsoft, which then do the web search for you. You can then consume those that data and response, do some kind of summarization, decision making over there. File search, it's grounding prompts data from files in a vector store. Azure AI Search Fabric, you can do some kind of as well licensed data, integrate third-party license data by using Open API specification action tool. This is some kind of integration specification standard these days. And we have action tools, code interpreter, function, Azure function, Open API specs. So lots of the stuff can be achieved here. As been said, modern systems are not consisted only of one agent. They are consisted of the multi agents which are communicating by themselves. Analogies, obviously, again, the team, you have the team of different kinds of personnel. One is specialized for this area, second is specialized for this area, tasks, third is specialized for this, and they need to share their workloads and they share their informations to accomplish certain task that you gave him, and which is then divided on the subtasks and then combined into something that is final output. Same thing applies here for connected agents, and already mentioned the MCP. I will not go in depth, but this is important stuff. You have here support from the Foundry to set up multi-agent system. Agent that calls other agent for specialized tasks, maybe literature agent, call a statistical agent, call a report agent. Each agent has its own model knowledge and tools. MCP, Model Context Protocol. This is something that was 1 year ago proposed by Anthropic, and it's heavily adopted by every single big corporation who is building agentic AI systems. This gives us open standard for connecting agents to external tools. Besides that, we have A2A protocol from Google for communications with agents. So, for instance, you can connect to the data to some kind of institutional repo, lab instruments, data systems, and work with any kind of AI platform supporting MCP. And today, every single platform does that. So, by me, you can build up your agent here. The other institution builds up the knowledge toolbox, which is hosted in AWS, but you want to consume this, you can do this because it's enabled through this protocol. Here is some kind of architecture, and I will just show you in the next few minutes how this thing is working. We have researcher, okay, who is building researcher agent. Behind it, we have GPT-4.1 model, which is that brain, this decision-making engine behind. We gave we gave different kinds of tools to it. Here are listed some kind of other tools that can be even connected to it. File search, Azure AI search. We have code interpreter, which is then served for generating charts, tables, and reports. Let's see how this thing is working in production, and how can you easily, in just a few minutes, create your testing AI agent. So let me again just switch to the browser. Okay. So we are here. And there is a blade called agent. And as been explained, we already have here created agent. I will show you all the details, but you have option to create the agent. This is just some kind of Microsoft notice about they are going to change this user interface soon, but for our purposes, this is okay. So we have opportunity here to create some kind of agent, host it, etc., etc. We are going to, we are not going to update anything right now. We are going to go in a classic Foundry. Okay. You are giving the agent name. You are giving some kind of deployment. By deployment, that means the model behind. We have multiple different kinds of models here, which can be served as a brain for decision-making rationalization. We are giving main instructions over here. You're a researcher data agent specializing in European water quality analysis with some kind of generic currently instructions. We have agent description. What does he do? He uses certain tool called code interpreter to load datasets, run statistical analysis, generate charts, etc., etc., etc. Okay. We have one action over here. Knowledge currently we did not connect to anything, but you can imagine that we could connect if we have a large amount of data to some kind of vector database, which will be then served as a grounding point. We have action. And code interpreter over here. We did upload for code interpreter European quality raw, some kind of CSV file that we've been playing around last time around it. Okay. So we get a context of this. We have model settings for temperature and top P as well. And we can even connect some kind of new agents. Do not bother a lot about this. This is just due to Microsoft and changing the platform in general to connect. But what is important here, we can, once when we establish this agent, he's deployed on a Foundry infrastructure, and we can try to start chatting with it. Okay, let's see what we can ask our agent. Just give me a sec. Let's ask him something like that. Okay. So you can see some kind of traceability over here, what is happening behind. Have in mind that we provided him some kind of dummy CSV file with some kind of statistical data, and he is doing complete analysis right now. We asked him, load the data set that we gave him already, provide statistical summary of all numeric parameters, how many samples do we have, what is the data quality. Okay, that's analytical approach. Our agent, you can copy the response. You can see this is our agent. This is his analytical approach in terms of how he's going to solve this task. He's going to load, he's going to inspect, he's going to generate descriptive statistics, and he's going to do that. And he started to do it by code interpreter. In the background, you can see what code interpreter practically is. It's a sandbox executing the Python scripts. And you have complete isolation to working on your data on some kind of sandbox, which is built into this agent and executing different kinds of libraries, etc., etc., etc. That's the cool stuff. So agent knows how to interpret Python code, execute it, and interpret the results going back from the Python code. This is code interpreter in general. Okay, so he's doing this in the steps. He found 508 samples. Column names are those. He's again doing some kind of analysis, and he did some kind of executive summary for us. Sample counts. We have the numeric parameters. He is giving us the overview of the data overneath. He's giving some kind of ratings of data quality limitations, etc., 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 and giving some kind of summary. So we did by providing hosted model, by providing system instructions, and by providing the CSV file with some kind of, in my case, dummy data, we established a full viable agent who can do some kind of Python stuff for us and do some kind of analysis, and it's ready to be adjusted, to be tested here in the playground, to be hosted, etc., etc., etc. So you see here, for instance, how can you consume this AI agent which is hosted from the Python, from instance. So you can use following code, start integrating current agent and thread into your application. Why is that cool? Because maybe you have some kind of different department which is responsible for doing user interfaces or whatever, and maybe you want to use this agent in your Jupyter notebook. You can do it just by using this code. You see some kind of libraries that you need to import over here, where is the endpoint, some kind of code and stuff like this, and you can do it by just a few pieces of the code. And this is something that is living in the Sweden. It's EU protected by all laws. Everything is done in the Microsoft infrastructure, and you can just consume it pretty easily. So this is our agent. Just let us ask something again. On top of this, analyze dissolved oxygen trends. He does analytical approach. He loads code interpreter. Okay. So this is just some kind of rate limit that I checked on the model in general for limiting how many communication can I do in one session, but you understand the concept in general, yeah. And what's the important stuff here? You have full thread. What happened? Message creation, which kind of tool has been called. You can check the logs for it. Message creation, some kind of metadata. So you can treat this as some kind of debug example or debug feature. Okay. So what we just saw, we saw that agent that is built up in Foundry autonomously read, understood the dataset structure, wrote, execute Python code for statistical analysis, generate some kind of data that can be used even in some kind of examples later. Charts can be generated as well, because you know that you have execute some certain Python libraries that can draw the charts over here, run correlation analysis, etc., etc., etc. And this is important that every step is logged, code is visible and reproducible. We are getting closer to the end of our session, so I want to wrap it up everything. There was a lots of information going on in this our session, and in these 2 hours, obviously, we had the chance only to have a sneak preview of it. But from the perspective of your research AI architecture, you should think of different kinds of layers which are necessary for you to do your job. For instance, your going from the perspective of your output, you have reports, charts inside publications. And to do this, to achieve this, you can use the AI layer, Azure AI Foundry, where you're able to provision different kinds of models, compare them by different kinds of evaluation points. You can build up the agents. Agents have possibility to not just summarize data, but to execute different kinds of stuff. We saw in our example that we execute the tooling called Code Interpreter, which is then executing Python scripts in a background. We can do some kind of evaluation, set up content filters, important stuff here. Knowledge layer, ground our agents and our whole workloads with the data, which is stored and vectorized for the RAG purposes, in the Azure AI search, in the vector indexes, do some kind of file search. And beneath that, we have, as we learned in the previous 2 sessions, we have data layer, which is Microsoft Fabric in our case, where we have data which is non-structured, structured, whatever I like to do, in a lakehouse, Mendelian architecture, pipelines, and doing some kind of ML flows and connection, everything. So you can think of the AI Foundry, something that can be examined, inspected as a standalone product, which can help you to build up the AI agents and to leverage all features of the AI by itself, by provisioning multiple different kinds of models. Important stuff to remember in the region which you select and under the regulatives which you are, which we are all under it. And you can even have some kind of data in data lakes like like Microsoft Fabric, which can then easily be connected and to have a whole pyramid, whole pillars of everything around it. So you are then focused when you connect everything there only on the output. Reports, charts, inside publication, AI can help you to speed up you in everything around it, generating text, some kind of data mining, some kind of chart generations, some kind of companion in brainstorming around the stuff. You can do everything. Before going in the Q&A part, just wanted to give you some kind of links and some kind of overviews where to go from here. There's lots of Microsoft Learn pods which are free, self-paced. You can go on the Microsoft Learn portal, go, for instance, on the track for AI 102, designing and implementing Azure AI solution, where you can go deeper in all this, which we try to tackle in these 2 hours. Building generative AI solutions, you can go analytic solutions, you're using Microsoft Fabric, deep dive, building AI agent solutions, MLOps focus. For hands-on labs and self-study, for sure, on a GitHub, Microsoft Learning, lots of stuff is over there. From where you can go in lots of different kinds of examples, play around with it. I'll be talking about that you will play around in your existing environments in Jupyter or whatever, preparing AI development projects, explore comparing the models in a catalog, create generative AI chat applications, apply content filters, fine-tune language models. All those examples are over there and you can tackle it in the details. AI agents, build agents in a portal and VS Code, for instance, if you're using VS Code, custom function tools, code interpreter, so you can do everything around it. Okay. This is one thing to already been mentioning in our previous workshops, but not sure if you are aware of it. So check in your institutions that You can get up to $20,000 in Azure credits for academic researches. You need to apply for it. Probably your institutions maybe do have some kind of access to this to play around with technology and to start to dig deeper into this and not spending any budgets that you already have, So check Microsoft.com Azure Research for this. You have trial for Fabric to play around with it for this capacity. And even if you want to have some kind of Microsoft certifications, you can even go in AI 102, and AI 103 is going to be a new one. It's going to be the refreshed certificate from Microsoft, and DP 600 for data fabric engineering. And I would stop here before finishing everything. And I think I left some kind of 10-ish minutes for you guys for Q&A time. So feel free to ask me whatever it's on your mind and on your heart.
Thank you, Mario. That's really, really interesting. And that last demo was really fascinating because it showed the power of AI to help researchers. Because if you're a researcher in water quality or air quality or whatever, then you're not actually necessarily a programmer. You're not going to be able to do all of that work that the agent can do on your behalf. And that's the real power behind these things, is that you can actually basically hire effectively an expert, a coding expert for the 30 seconds or 2 minutes that is required um, to do that kind of work for you. And having the traceability is also important there as well. So that's really, really fascinating. To everybody on the call, thank you very much. I know it's a long session, but we have got through a lot of information there. And if you have any questions, then please unmute and ask away. I'm sure that'll be fine. We will also be I will get Carmel and Sandra to pull together all of the URLs in that last section there about all the courses, and I'll be sharing that with you guys afterwards once we've got actually a kind of a document with all the URLs in there, so you don't have to worry about hunting around and searching for those randomly. So, does anyone have any questions for the moment for Mario?
Nothing.
Nothing.
Yeah.
That's either extremely good news, or extremely bad news because everyone's asleep. But I'm sure they're not. So I'm sure it's all very good news. Well, what I will do is I will say thank you very much again, Mario. Really interesting. I learned a hell of a lot, and I'm sure that all the people here will have learned as well. What we'll do is we'll also have this recorded and shared out with you all afterwards, with those URLs that Mario was talking about at the end there. So I would say thank you all for attending, and I will give you back 5 minutes of your time so you can get off to have some lunch before your next call and meetings and so forth. And we'll see you all again, hopefully on the 29th. Thank you very much, everybody. Take care.
Yes. Thank you very much. Cheers.